next chapter we are going to be doing is on trigonometry and connecting the trigonometry of triangles that we've done to trigonometry in circles. So you'll see where that comes from today. And we'll review and start with a little bit of review of what you already know. So if you turn to page 466, you have some room on the side. We're going to start off with some definitions. And the first definition is, what does it mean when we talk about an angle in standard position? And we're going to start off by playing a game. And the game is angle in standard position or not. It's a very exciting game. And the way that this game works, don't write this down, is I draw a picture of an angle, and it's either in standard position or it's not, and we have to guess or decide where it's going to go. And then after we've done this for a while, we see, do we have enough information to correctly write the definition of what is an angle in standard position. So for example, we start with this one. This is an angle in standard position, so I put it here. But can't see. This one is not an angle in standard.
That's not you getting tricky with it?
No. Good music happening.
Over there?
Maybe. All right. This one?
No.
Is.
Yes?
Hmm.
Didn't I?
Yeah, stop.
That's yes, that's gotta be yes. Since it starts on right, like.
No, it's not. No.
What?
No, because
Yeah, okay.
Okay.
So each time I'm trying to think, is there something I haven't done which to clarify our definition? I haven't done anything here. Let's do something here.
That's it,
Yes.
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 That's
Yes. Very awkward yes.
Very, very weird. Yes.
That's gotta be yes.
Yes, obviously.
Obviously.
Yes. So it's gonna start from right. Yeah.
What a fun game. Like you can play this all weekend, eh?
That's a no.
No, I wonder.
That's a no. That's a no for me.
I do wonder.
That's an. I mean, my rule is kind of it has to start kind of from the right side. Yes.
It needs to start from one specific spoke of.
Okay.
Yeah.
So we think we've got the pattern that fits them all. What makes something one and something not? Okay. Now we have to write that in words. An angle in standard position what makes it an angle in standard position? What do you think? Alice?
I'm not sure if this is really the correct definition, but from using that graph, it is any angle that starts from the right side of the horizontal line.
Okay, so we're saying that all of these ones, if I draw in blue here, all of them started here. Why can't we just say x-axis? Because this one was bad, right?
Positive.
Positive x-axis, that's nice, right? An angle in standard position starts on the positive x-axis. So what we did here is we created a definition. I could have given you the definition, but by creating the definition from seeing examples that work and examples that don't, now you have a visual of what it is. Okay, we could play this game with any definition, but now we're going to start our next review definition. Reference angle. Very, very important for higher level trigonometry. You might remember it from last year, so I'll just write out the definition this time. A reference angle, and we show a reference angle depending on what variable we use, but we often use theta for an angle, so we put a little r to show that it's a reference angle. A reference angle is the angle between the terminal arm, that's where an angle ends, and the nearest x-axis. And I'm gonna add one word in here that's actually quite important. I can't believe I forgot it. Right in there. It's always positive. So when we label a reference angle, it's always a positive angle between the terminal arm and the nearest x-axis. So for example, and now we'll do some examples.
Could you give me the definition of terminal?
Yes. So for example, if we took an angle of 100 degrees, so our angle theta is 100 degrees, where the angle ends is your terminal arm. So terminal, it's like terminates, and for, it's true, like there's where a train ends, where does it end? At the terminal. So it does come from that word to end. Just terminal sounds so much nicer than terminates or terminator and things like that. But it's where the angle ends, and then the nearest x-axis, this would be the nearest x-axis, and we would say our reference angle is equal to, any guesses? Not guesses, can you figure it out? 80 degrees. Why? Because you know the straight line adds up to 180, so there would be 80 left. If you label your angle with an x, then your reference angle you label with an x with a little r. Whatever the main angle is, your reference angle just has a little r. Now we would have to think what adds up to 180 here would be 55 degrees. And even though the regular angle is negative, reference angle is always positive. There are some times that you are going to be tempted. I'm going to give you one that okay. Sometimes you're going to be really tempted to go to the nearest y-axis. Because it's like, oh, it's so close by. But no, even though it's only 5 degrees away from the y-axis, we would still say that the reference angle And this example is 85 degrees. Yes.
I don't understand it correctly. I thought the rule was just that it has to start from the right line, but not.
That is so that was our first definition. Our first definition was angle in standard position. So an angle in
Yeah.
standard position always starts from the positive x-axis.
No, I thought the reference angle was kind of the same, but I may have not.
So the reference angle is always the angle between the terminal arm. So now where the angle ends is the terminal arm. I will label that in purple. This angle ends here, this angle ends here, this angle ended there.
Mhm.
And the nearest x-axis doesn't have to be the positive x-axis.
Mhm.
The nearest x-axis. So in this case, it's closest to here.
Mhm.
In this one, it's closest down. In this one, it's closest to that. What about 90 degrees? If I gave you 90 degrees, what's the reference angle? It's 90 degrees. Which one is it closest to? Well, it's equal distance to either one. It'd be 90 degrees if you went this way, or 90 degrees if you went that way. But the reference angle would still be 90 degrees. So it's always the distance to the nearest x angle. And why is the reference angle so important? Well, it sort of gets back to, I'm going to sort of review what the reference angle does and also review something from grade 11 called the CAST rule, which
Never heard of it.
you never heard that, but it's just C for C, A for A, S for S, T for T. A stands for all, S for sine, tangent, and cosine. And what the CAST rule tells you is where trig ratios are positive. So for example, if I take sine, and I take sine of 30 degrees, this is going to review both reference angles and the CAST rules. This might be one you memorized last year. Without a calculator, you might have memorized this was half. Don't worry, we get to memorize it again this year without a calculator if you don't remember. Sine of 30 degrees is a half. If I draw a right-angled triangle with 30 degrees, and let's say I drew it perfectly, okay? Might have to use a little imagination. I then take out my ruler and I measure this, and I get 7 centimeters. I take out my ruler and I measure the hypotenuse, it happens to be 14 centimeters. Sine is opposite over hypotenuse. Can you see that 7 over 14 reduces to a half? No matter how big or how small I draw a triangle with 30 degrees, if I measure and I've drawn it perfectly, if I measure and I measure perfectly, it'll always be exactly 1/2, perfectly. Any kind of difference would be due to human error in my measurement, or I used a really thick pencil or something that threw it off. If I go to my calculator and I pick 150 degrees, well, 150 degrees is in quadrant 2, like so. But if I use my reference angle, it would have the same reference angle as 30 degrees. And if I make a triangle back to my nearest x-axis, and I check opposite over hypotenuse of that triangle, I'm also going to get a half. This is the power of reference angles. If you know a reference angle, if you know an angle in quadrant 1 and its reference angle, then all of the other ones that have that reference angle in your calculator will give you the same value. Yes.
What's SIHL?
This is,
Well,
this
yeah,
is an
it's
English,
I-
this is a Canadian one.
Yeah.
There we go. This is for Willie. There we go.
Okay, SIE.
Sine. This is short for sine.
Yeah.
Yeah.
And no, SIEH. The one down before the 150.
This one.
No, 150. Yeah, down the left one. No, SIH.
This.
You're saying
To the 150 there.
150.
Yeah, a
on the
little bit to the left. The letters there. What's
This
that?
is just a bad looking N. I'm so sorry.
You just drew the end that way.
I meant to make a dot.
Well. Okay. Yeah.
And then,
Yeah.
and then when I made the dot and tried to lift my pen, I didn't lift it up, and it just made an H.
Okay.
Yeah.
Okay. Yeah.
We're good?
Yeah.
All right. No, it's good, because sometimes you're like, is this because of English? Or is my teacher just terrible? Usually it's gonna just be your teacher's terrible. But sometimes it might be the English.
Yeah. Well, I might have never
Right.
had that kind of topic in my
Mhm.
life.
I'll try to be very nice and neat. It's not the last very long. After 150, if I did quadrant 3 and had 30 degrees as my reference angle, I would have 210 degrees. And if I went to my calculator, I would get the half again, but my calculator this time would tell me negative.
I can follow.
Try on your calculator, sine of 210 degrees. You'll get negative 0.5. Right? So the reference angle tells you it's got to be a half again because it's the same reference angle. But your past rule says if you're in quadrant 3, only tangent is positive. So sine would have to be negative. In quadrant 2, only sine is positive, and sure enough, it came out positive. And if I would do 330 degrees, I'd get a half again, and it would be negative again, because in quadrant 4, sine is negative. Now we're going to see from the unit circle an explanation why that happens. In grade 11, we just sort of looked for patterns and saw why some were positive and some were negative. Now we're going to have those ideas explained a little bit. So that's the cast rule, and the only reason it's cast is it spells the word cast if you read it this way.
Mm-hmm.
It could have been the acts rule. It's just feels a little bit awkward to pronunciate that really well. Acts. And you might, is it A-X-E?
Acts.
Right? Or is it A-C-T-S? Right? If you read it, acts. You should maybe start in quadrant 1, but then it doesn't spell a word. Should it be the Astic rule? Could work. I kind of like that. It sounds kind of fun. Astic.
So tangent and cosine.
Tangent.
Tangent and
Or-
cosine are the negative ones, and sine and all are the positive ones.
No, this says where they're positive. So if I picked 210 degrees,
Mm-hmm.
okay?
That would go into target.
I'll go up here, I'll just write 10 of 210 degrees. If I go to my calculator and check that out,
Mm-hmm.
I will get a positive number,
And for
right? Try it on your calculator right now.
yeah, the problem.
Tangent of 210, sure enough, it gives me positive 0.577. But when I did sine, I got negative. And if I would do cosine of 210 degrees,
Mm-hmm.
You get negative.
I get a negative number again. And sure enough, cosine of 210 degrees is negative 0.866. So if you know where the angle is, you will know if it's positive or negative before you push enter. Often though, we don't have the numbers all memorized for like, what happens if I do sine of 3,852 degrees? Oh my goodness. Well, I first have to figure out where the heck 3,852 would end. Quadrant 3. So I would know that sine of 3,852 is going to be negative. But after that, it's a little bit tricky to figure out exactly all the decimal places without a calculator.
Wait, what did the mental map look like for you to figure out it was in quadrant 3?
Oh,
I'm curious.
what a nice segue.
It's 252.
I did 360 degrees times 10. Okay? 360 degrees times 10 is going to, right here's 0. If I go 360 degrees, I'm going to end here. If I go another 360 degrees, I'm going to end there. If I did 360 degrees 10 times, I'm going to end there again. Okay? And then I would have to add, because that's 3,600, another 252 degrees more. So it has to be in quadrant 3. So I know that this angle ends right there. Which leads us beautifully into our last definition that we're going to be looking at. Co-terminal angles. And if we use some stuff we know about English, the definition comes together very nicely. English words, not all of them, but a lot of English words that start with co mean to share. To cooperate, share the work, do things together. If a dorm is co-ed, then girls and boys in the same dorm.
I assume cosine doesn't follow that?
No, so there's some that don't, right? And there's some that, right? Like a chicken coop has co in front of it, but it's not even co. It's not co, or, right? Coca-Cola, no, that has nothing to do with it. So just because it starts with C, but often things that start with CO, but then have another word after them, do mean to share something. Okay?
Shared angle.
Coterminal angles, two angles are coterminal if they share the same terminal arm. In other words, they end at the same place. So two angles are coterminal if they end at the same place. So we would say, since this is 252 degrees, and this is 3,852 degrees, and they end at the same spot. They're coterminal. Now you might not have noticed, but what I just did is I hypnotized you with that spiral. You are currently in a hypnotic stance. You don't even know it. I can do all sorts of suggestions and stuff like that. And then like when I snap my fingers, you won't remember any of this. Okay? But there might be some, like, you like math. You like doing your math homework. So when I snap my fingers, like tonight, you might just be like, oh, I feel like doing my, I don't know why. I feel like doing my math homework. Okay. Right. Which. So this is the idea of two angles being coterminal. And if you turn the page to 468, they have the definition officially.
Which slide? Which page?
Page 468, right in the middle of the page, they have this sentence, if you want to highlight it. Oh, too much for the definition. We can highlight it. So if you had 40 degrees and you added 360, you would get to 400 and you would end in the same spot, right? And if you added 360 again, you would get to 760. We can also subtract 360 to end in the same spot. So if you're asked to ever find an angle coterminal with something else, you could just add 360 or subtract 360 as many times as you want, okay? But they're still different angles, right? For example, if I'm skiing, there's a bit of a ski jump, and I go off that ski jump, and I land. I might have done a 720 and spun 2 times in the air, but much more likely I did a 0 degree. I just went up and landed, and was happy to have landed, right? But doing a 720, I would end in the same spot, and if no one was looking, I'd be like, yeah, I just did a 720.
Yeah, sure.
But it looks the same as a 0 degree, because it's coterminal. But they are different angles. One of the things I'm going to get you to do is I'm going to give you questions that say, could you write out all the coterminal angles with 40 degrees?
No.
I've got to start. Here's 1, 2, 3, 4, 5 of them. You just have to write the rest of the infinitely many. So we have to, yeah, that's a problem, right? How do you write down an infinite amount of answers without dying first? By code.
Serious?
I sort of use a code or a series. We use some sort of formula to explain it. And the formula that we're going to use is we're going to say, if you would like to find any coterminal angle, start with the one that you have. Then if it's going to end at the same place as 40, you either have to add 360 or subtract 360. And you could keep doing that as many times as you wanted. I could put a plus or minus, but I'm just going to put 360 degrees, and then I'm going to put the variable k, and say that k can be any positive or negative whole number, in other words, any integer. If k is minus 3, does it give me a coterminal one? Yes. If k is 7, yes. If k is 0, I get 40 degrees. Does 40 degrees end at 40 degrees? Yes. They are coterminal.
What's the Z stand for?
The Z stands for integers. Wow. Which means dot, 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 -2, -1, 0, 1, 2, 3, dot, dot. All of our positive and negative whole numbers. Okay? It comes from the German word Zahlen, which means number. Sometimes American textbooks use I for integer, and maybe you saw it sometimes in earlier years they do that. Internationally, this is used more.
Going mathematician, you better know that one.
Right, so real numbers is an R, not sure which language it comes from. Because maybe more than one language use real for that. So.
Imaginary numbers are those.
Okay, let's go to example 1 now. This is on page 469. Example 1, determine the measures of all the angles between negative 800 and positive 800, which are coterminal with 85 degrees. And this would be 85 degrees right there.
Does 85 degrees itself?
Yes.
One of the
85 is coterminal with 85. I would write it down as one. If you added 360 degrees, change colors here, you would get 445 degrees. That would look like this, starting here, around once. $445. If I did it again, I'd have 805 degrees. Are you okay if I just I'm just gonna put an X through that. I checked it, it's too much because we only had to go up to 800 degrees. If I subtracted 360 degrees, does it work out to negative 275 degrees? Question.
How is 445 plus 85, 805?
Plus 360,
Oh,
right? Because we always do a full turn. Yeah. Negative 275 would look like this. And if we subtract 360 again,
That's 3.
someone hopefully is double checking my mental math.
Yes.
Negative 635 degrees. Uh-oh, looks like it happened again.
Isn't that
You really like math. And you really want to get your online free quizzes done.
It's a real shame that I haven't been looking to do either of these.
You have another big quiz?
Just the one that's due tomorrow with the second take-home quiz. Okay, then part B. Write an expression for the measures of all the angles that are coterminal. It's sometimes easier to do all of them because you take 85 degrees. You could add 360 degrees as many times as you wanted. So we put the variable k in there, and then we define that k could belong to the integers. Questions for practice? Are 4 and 5.